Welcome to your video on the supplemental concepts that are featured in Unit 3. These are not in your textbook or not covered as well as I think that they should be, so I'm going to go ahead and go over them here. Okay, first thing that you need to know, and this is just a straight up vocabulary word, is that the word potable means fit for drinking. Some things like Greywater and reclaimed water, which are used for irrigation, which means to water plants, it's not potable. It's not made for human consumption, basically, so just keep that in mind. All right, tap versus bottled water. We watched the story of bottled water in class. That may be something that you want to watch, but what you need to realize is that tap water and bottled water are overseen by two totally different organizations in the government. Tap water is overseen by the Environmental Protection Agency. The water has to pass over 80 quality tests. It's overseen by natural law. This is the stuff that comes out of your tap. Bottled water, on the other hand, is regarded as a food, so it's spot checked by the Food and Drug Administration, which is what FDA stands for. There's lots of exemptions. Fluoride is not added. In other words, bottled water is not as high of a quality as tap water is. Plus, it's more expensive. All right, there is a link between water temperature and dissolved oxygen. The warmer water gets, the less dissolved oxygen it can hold, and conversely, the colder water gets, the more dissolved oxygen it can hold. This becomes more important when we start talking about climate change and our oceans getting warmer, the implications being the warmer the water gets, the less oxygen it can hold, and thus you're going to start seeing more fish kills. Oxygen Sag Curve. This is the idea that if a stream is being polluted, so you have a point source of pollution of something like human waste, decomposing bacteria, aerobic, the same ones that eat dead algae and plant matter that occurs during eutrophication, when they do their thing and they go crazy because they've got a huge food source, which they would if there's point source pollution that they could decompose, they suck all the oxygen out of the water, so they create a hypoxic zone, a dead zone. So in other words, if you're graphing how much oxygen there is in the water, the curve, it curves, it sags. So if this was, this y-axis was amount of oxygen in the river, as you can see, there's a dip. You would be tempted to think that the lowest amount of dissolved oxygen would be directly under the pipe. That is not true. Because the water is moving, the bacteria do not reach maximum capacity in pulling oxygen out of the water until a little bit downstream. So it starts under the pipe, but then that oxygen dips to almost nothing a little bit downstream, and then eventually it picks itself back up as the bacteria do their thing, and water flow dilutes the waste and so on and so forth. So just be aware of that this phenomenon exists, and if you're presented with this graph, that you're able to interpret it correctly. All right, parts of a river, you need to know that the watershed is all of the land around a river, but it's the highest points to then the river is at the lowest point. The implication being so it rains, and the rainwater, because of gravity, runs into the river, but that rainwater is going to pick up any pollution that exists between where it hits the ground and where it runs into the river. So when you're considering the health of a river, you've got to consider what's going on within its watershed. You need to know that the source of the river is also called the head. Then you have the mouth down here. It's cold, clear, and quickly moving up at the head, slow, full of sediment, and less oxygen but more life down towards the mouth. And here are all the bits here. This is called a delta down here at the mouth. It widens into a triangular piece. All right, prairie potholes. This is other types of freshwater wetlands. The ones that you learned in class were marshes, swamps, and bogs. Prairie potholes were formed by glacier ice. There's two ways that the glaciers influence the creation of the lakes. First, ice is heavy, and so it pressed down and created a little divot. Then as the earth warmed up, and then also sediment built up over the ice, eventually the ice melted into water, and it filled the dip created by the glacier in the beginning. This is The prairie, this is the United States, the prairie is in the Midwest. So just realize that's why those lakes are there. They are freshwater ecosystems. All right, floodplains, it's rivers that when they crest, which means when they get really high, when they become full of water, like after spring rains, or lots of snow melt up at the head of the river, water overflows what's called its banks, and it floods the surrounding portions of the river. This happens towards the mouth of the river. This is perfectly natural. This is not something that should be stopped. The ecosystem here depends upon these regular floods. All right, and then the Arctic tundra for 1 or 2 months of the year is also considered a wetland. It gets very warm, very wet for just a few months out of the year, super high productivity. This is why animals will go here to give birth to their young, or birds will lay their eggs there because it's very easy to feed the chicks and get them the heck out. All right, Thermocline is analogous, not analogous to, but it goes along with a pycnocline. A pycnocline is where the density of the water increases rapidly as salt content increases. So a thermocline is where the temperature drastically decreases. Take a look at this graph. You're going to see surface water here is very warm. Y-axis is depth, x-axis is temperature, and then they have this thermocline where it gets very cold very quickly, not a lot of depth change, and then the temperature, while it gets a little bit colder, there's not an appreciable change in the temperature at these depths down here. All right, lakes in the wintertime, please realize that a couple of things. First of all, if ice didn't float, lakes would freeze solid in the winter. Because ice floats, ice is also insulatory, so it keeps the lake above freezing temperature. However, because of this thermocline that develops in the middle of the lake, you don't have any oxygen circulation, you don't have any sort of downwelling that's happening, so fish down here at the bottom in the profundal zone either die or they go into what's called torpor, which means they don't need a lot of oxygen to start with. Then you can see, although there's no ice here insulating in the summertime, you have a similar situation where you have a sharp division of temperature in the water, so you do not have, again, that oxygen circulation going on. Spring and fall is when the bottom layers are the most oxygenated by convection. All right, when you drill a well, and by the way, I know I'm bouncing from topic to topic to topic, but that's kind of the nature of this particular video. When you drill a well, it's like punching a straw into a cup of liquid that has ice in it. In order to be able to drink the liquid, the bottom of your straw has to be below the level of the liquid. Where the liquid starts, if you were to compare that to an aquifer, is the water table. And if you are withdrawing water from this aquifer faster than it can replenish itself, well goes dry and you have to dig it deeper. Places like California, they're drilling wells upwards of a mile deep and they're having a tough time hitting water. So another consequence of aquifer depletion is that you've got to sit there and drill your wells deeper and deeper, which becomes a expense for those who depend upon that water source. All right, subsidence, your book alludes to this. When you have an aquifer and there's no longer water in it, the water is what keeps those pockets open that are in the aquifer, and so then anything that's built on top of it kind of crushes the pockets and it slowly settles. If you have a place like Mexico City, it has dropped many, many feet. You can see it also does it unevenly, so you have buckling in the road and churches tilting to the side, foundations cracking, that whole thing. All right, saltwater intrusion, again, your book alludes to this. They don't use this term. Coastal aquifers. The freshwater keeps the saltwater out through what's called osmotic pressure, and that only occurs when there's a lot of freshwater in that aquifer. So if you overdraw from the aquifer, meaning that the amount of water in the aquifer decreases faster than can be replenished, that saltwater then has the superior pressure and invades the aquifer, basically tainting it all with saltwater. Clearly, saltwater intrusion cannot happen in inland aquifers because there's no ocean. This is only characteristic of coastal aquifers, like those in Florida. All right. One of the problems with a dam, when you dam a river in a freshwater situation, migrating fish hit that dam, hit the dam, and they can't get through to go to their spawning grounds upstream, and they die. Side note, in case you don't understand how this works, some fish are born upstream, and then they follow the stream and they go out to the ocean. Salmon is a great example of this. Then when they're adults, they swim back upstream. They're kind of programmed to go against the current so they can go back to their spawning grounds, lay their eggs, have them fertilized, and then die. All right, so the way that you have both a dam, which is beneficial to people, and then also don't block the migratory paths of fish who need to go upstream, you build fish ladders. So as you can see here, you jump from pocket to pocket to pocket until you get beyond the dam and move on, and you can see here are some more fish ladders. So a very elegant solution to this problem. All right, gray water is water that has either been partially treated or it does not contain waste at all. So things like from your shower or the laundry or your dishwasher is then collected, slightly treated, not a whole lot, and then used for irrigation purposes. And oftentimes the detergents that people use or some of the things inherent in the wastewater have things like nitrates and phosphates in them, so they end up being a really good idea. Plus, it saves money. So this is usually something that happens in an industrial setting, or even in individual homeowners can sometimes do this as well. And so not only does it help the environment, it helps your wallet. A Secci Disc looks exactly like this. Circle, four pie wedges, 2 of the wedges are black, 2 are white. It's on a rope, and you lower it into the water until you cannot tell the black patch from the white patch. You mark how far down you put it, and then you use a graph to produce a Q value that will let you know the turbidity of the water, and then you can use that Q value to calculate water quality index. U.S. Water Quality Act supports state and local cleanup of polluted runoff. Loans are made for treatment plants and estuary protections. This was kind of folded into the Clean Water Act a little bit in 1977. There is no prosecutorial bite to this, nor is there the ability to do large-scale cleanup of things like hazardous waste. All right, brine is extraordinarily salty water, and this is one of the byproducts of reverse osmosis, as you can read on this slide. It is discharged and is also usually warm, discharged back into the ocean where the original ocean water was pulled out of, and it can shock marine life to the point that it kills them. Plus, it does interfere with water's ability to take up dissolved oxygen. All right, waterborne diseases to know. You need to know one of each for the national exam. I would. So bacterial, typhoid, and cholera are good. Viral, hepatitis B, and then protozoa. This comes from the Giardia protozoan little single-celled critter. Two out of these 3 things, the bacterial and the protozoan, you can see that diarrhea and vomiting are a huge facet of this. We're going to talk more about that particular types of diseases a little bit later on in our human health unit. And then Hep B attacks the liver. All right, not all countries have water quality laws. So if you look at this is the Ganges River, which is the largest river in India. It is a river used for all sorts of things. It's used, people wash their clothes there, people take their cattle to drink there, and they're not potty trained. You can see these buildings here, and this is a point source pollution probably from these buildings. I have no idea what's coming out. You can see that a part of their religious rites are to bathe in the river on the regular. It's also a part of their rites to cremate the dead to release their soul, and then they dump the cremains in the river. They also throw in painted statues that may be made with toxic heavy metals or painted with paint that include toxic heavy metals. Why do they do that? Because it makes the paint colors brighter. All right, and you can see here again the religious rites that are involved here. You don't always have to test water directly, in order to figure out if it's healthy, you can rely on indicator species. Things like nitrates and phosphates. If you see a bunch of cattails growing, as an example, you know that there are a lot of nitrates and phosphates in a particular freshwater body. The cattails are those things on the top that kind of look like the hot dogs on a stick. And then down here, this is especially true of streams. There are certain types of, these are called invertebrates, that you can count them and do like a transect study or a quadrat study and see how many of these little guys there are. And the number and the type tells you how polluted the water is. All right, there are alternative ways to clean water other than the massive water treatment plants we have here in the United States. Lower left-hand corner, UV light passing through bottles that's on top of a reflective metal pan for 12 hours will kill the majority of the bacteria that's in there. This is a filtration system made out of gravel, sand, and charcoal. And then you can see here there's a thing called the life straw, which purifies the water as it's sucked in from the bottom and hits the person's lips on the top. Think about all the problems that third world countries would have in reference to this. One problem is that people may not know to do this. Another problem is they can be very distrustful if this is coming from Western sources. And then another problem is that things like the life straw, they can't afford that because after 10 or 12 uses, this is no longer any good. All right, pharmaceuticals, that means medicine. Trace pharmaceuticals are popping up all over the United States because our wastewater treatment plants are currently really not built to take them out of the water. People will flush their medicines down the toilet when they're done with them because they don't want to keep them around and have them stolen or used by people who come in their house. Plus, when people are using medication, invariably you end up urinating out a little bit extra. So it's everything from birth control to antipsychotics to painkillers, anything that you can think of. Has started popping up in our drinking water. No, I don't have an answer to this. That's just something to be aware of because we don't know what the long-term effects, if any, are on people, especially our infants and children. All right, couple of terms to know: plankton, nekton, benthos, and decomposers. You should know what decomposers are. Benthos is anything that lives in the benthic zone, so oysters, clams, worms, lobsters, crabs, they're all filter feeders. All right, plankton, don't swim so good. Nekton, swim good. Although the majority of plankton are microscopic, not all of them are. Heck, some of you who are listening to this could be plankton because you don't swim so good. All right, here are some examples of plankton. Here on the left, you have phytoplankton that perform photosynthesis. Here on the right, you have zooplankton that eat the phytoplankton and kind of start the food chain. And then here you have some jellyfish that are plankton because they don't swim so good. This one here on the left is called a by-the-wind sailor. The reason it has this like peaked thing, it's thin, it's a sail, and so it catches the wind and it just blows it wherever the wind takes it. All right, Neritic and abyssal zones. The Neritic zone goes from the continental shelf to the high tide mark. Don't forget this oceanic zone is also called the pelagic zone. And then the abyssal zone is basically the deep, deep, deep part of the ocean. All right. So, hydrothermal vents. This is a place that only chemosynthesis takes place. There's no light, so there's no photosynthesis, so it's chemosynthesis that kind of keeps this whole thing going. Let me go back here in a second. I think what I'm going to do is, this is kind of labeled kind of weird. Before your test, I'm going to make sure that I draw this real quick so that you guys have a better sense of which zone is which. All right. And again, I don't expect for you to know the formula for chemosynthesis. It's kind of cool to note that it does depend on not only the heat from the hydrothermal vents, because these things get ridiculously hot. It also spits out sulfuric acid because it depends, this is a sulfur-based thing that goes on in order to make this carbohydrate. All right, types of coral reefs, just be aware that they can start from the shoreline and go out. They can be separated from the land that it's associated with. It's usually an island it's associated with. Be aware that the Great Barrier Reef off the coast of Australia is the world's largest. Then an atoll is one that circles an island. That can be problematic because people like to come to and from the island and ship things to and from, and so people have a tendency to blow up part of the coral reef so they can get their ships in and out. Okay, here's the Great Barrier Reef. It only grows an inch a year, which means when it's harmed, it takes a long time for it to come back. Just briefly look at how rich in biodiversity this particular area is. Whales will even come visit during the winter and sometimes have their babies here too. All right, just be aware that marine food chains are a little bit longer than terrestrial food chains. Happy story for you. This is a restaurant in Israel. You have to go here to this house and then go down. This is actually a coral rehab facility. You can see the guy here. They take coral from other places in the Red Sea, put it on little frames, give it antibiotics, let it convalesce here, for lack of a better term, and then take it back to where they got it from so that it can be all better and rejoin its coral reef mates back where it's from. All right, Purse-Seine netting is the fourth fishing technique you need to know. In this one, it's either a long strip of netting or it is a circular netting that has a drawstring around it. So you position it so that it's around a school of fish, and then you pull it tight all of a sudden, and then you haul in. See how this looks like a purse? And it just spills everything out. I want for you to take a look at how big this thing is. Okay, everybody's like, oh, you can catch a couple hundred fish. It's like on Finding Nemo. It's not so much. No. Ginormous. Okay, and as you can see, as with the other three fishing techniques, sea turtles invariably end up getting caught up in as bycatch. Biomagnification. This is also something I need to make sure that you understand. Some things like mercury are stored in the fatty tissues of organisms, and because they can't be flushed out, it means that if you have 8 little bits of algae that have next to no mercury in them, and fish come and they eat 2 of each, so now you have 4 fish that have 2 bits of mercury in each one, and then larger fish come and eat 2 of the smaller fish, and each one of the larger fish has 4 bits of mercury in it. And then an apex predator comes and eats the larger fish, and now that largest fish has 8 bits of mercury in it. So we went from something where each little bit of algae had only 1 bit of mercury to an apex predator that has 8 bits of mercury in it. So that is, it bioaccumulates in one organism, and then it biomagnifies as you move up the food chain. One such apex predator is humans, and because toxins hit little dudes heavier than big dudes, it means that fetuses and infants who are exposed to this, usually because they're either within their gestating mother or through breast milk, are hit the hardest by these types of toxins. Baleen whales, I just want you to be aware there's 2 types of whales. There's toothed whales like orcas, and there's baleen whales, which have these toothbrush-looking things in their mouths, and that's a giant tongue. So what they do is they gulp a mouthful of water, as you can see here, that's full of little tiny shrimp called krill. And then they use this tongue, and then they shut their mouth. And then they use this tongue to force the water out through these toothbrush-looking things, leaving the krill behind. Now, sorry this is a little graphic, but it is what it is. This has to do with the capture of baleen whales, which you can see that this one has been harvested, and then also these are tooth whales. These are called minke whales. The international community has banned the harvesting of whales except for 2 countries, and that would be Japan and I think Norway. Don't quote me on that, I'll check and find out, but definitely Japan. What Japan likes to do is to harvest the whales, and they'll harvest upwards of 1,000 a year, and given that these are case strategists, that's a lot. And they will sell it to the people in their country under the guise of tuna, because tuna is getting hard to come by these days. There is a loophole in the international treaty to not go after the whales that says that you can harvest whales for research. So the Japanese call all of their harvesting ships research. I'm not making that up. That's what they do. All right. The Marine Mammal Protection Act of 1972 is a U.S. law, and you cannot harass, hunt, capture, or kill marine mammals in U.S. waters, and then U.S. citizens can't do that anywhere. And there are exceptions for scientific research and then also for Native Americans. Pacific Ocean Garbage Patch, I encourage you to watch this TED Talk. It's less than 10 minutes. You can see here in the middle of the Pacific Ocean Garbage Patch, the guy has harvested just by dipping a net in the, or just kind of dipping a little cup in the water. There is more plastic than water in this part of the ocean. And there are two patches because the currents have taken any random plastic that's in there and kind of shoved it into these two places. And the patches are twice the size of Texas. You can see that this one is in between the United States and Hawaii. And it's about, we estimate it's upwards of 300 feet below the surface of the ocean. Now, they're usually not big pieces like this because the action of the waves breaks it up into tiny little bits, and then sometimes the bits are tiny to start with. So down here in the lower right-hand corner, this is typical of the size. And here you can see on the left a typical sample from the Pacific Ocean Garbage Patch. So who cares, right? Here's why we should care. Sea life is consuming this stuff. And plastic doesn't pass very well or at all through the digestive system. So this is an albatross chick, and its mama fed it all of this, and it felt full as it starved to death. And here you can see that this fish was harvested with little bits of plastic in it. Part of the problem with plastic is that it absorbs and then releases toxins, and it does have toxins in it itself. So if this is a little fish and the toxins are released into it, you can have biomagnification occur. So yeah, this is hugely problematic, and this is one of the consequences of the proliferation of plastic products within our lives. Now, plastics really didn't hit the scenes before the 1950s, so this is a relatively recent phenomenon. All right, we've talked about the Exxon Valdez spill. Still a huge problem. This was 11 million gallons of oil. Well, we just recently had the Deepwater Horizon. I believe it was 2010, not too long ago. This was when a drilling platform, basically a gas bubble, formed, and as gas rises, it expands, and it broke it apart, and it set the rig on fire, and then basically it was like somebody punched a straw into the world's largest Capri-Sun full of oil. And you can think about the pressure of the earth like a toddler squeezing that Capri-Sun, except this went on for months. 210,000 gallons of oil leaking per day. All right? Completely eclipsing what the Exxon Valdez did from day one. This took months to seal, because you have to imagine if stuff is coming out at a super high velocity, it is really hard to inject anything and expect it to stay here and harden while this is pouring out. So this happened in the Gulf of Mexico. This killed the shrimp and the oyster industry, not only because the critters died, but also because nobody wanted to buy the stuff that was tainted with oil, and so you had a lot of fishermen going out of business as well. Plus, this ended up just washing into the estuaries that were along the Gulf of Mexico. We even here in Fort Myers had tar balls washing up, and this stuff is incredibly sticky when it comes out. All right, shark fin soup is considered a delicacy in Asian countries. You can see it here in the lower left-hand corner. These fins are more profitable than the rest of the fish put together, so there's no reason to keep this the shark. So you just catch a shark, you slice off its fin, and you dump the rest of it back in the water, and then you dry the fins and you take them in. And you can see that this is just one harvest here. You can imagine, if you did this all year, what would be happening. Sharks serve a vital function. They eat dead and dying organisms, so they help to maintain the health of the organisms they feed off of, survival of the fittest in this case, the most suited for life in the ocean. So this is still very problematic. And then brackish water is what the water is in an estuary, because river water is fresh, ocean water is salty. So brackish means kind of salty, and the implication is also that the level of saltiness varies depending on high tide, low tide, and where you are in the estuary. And then lastly, I don't know if you've ever thought about how marine organisms cope with salt water, because salt water is toxic normally to plants and animals. So these plants and animals have, through natural selection, had these adaptations arise that allow them to go ahead and cope. But they have to be constantly ejecting salt from their systems. This is a mangrove leaf. This particular type of mangrove ejects the salt out of pores on the bottom of the leaf. Upper left-hand corner, this is an albatross. Not only does it collect the salt and eject it out of its nose, it has a groove that directs the brine down its beak, and it drips off the edge. And then this turtle is not crying, it is letting go of salt. And that is the end of your supplemental material.